Barnett. All right, welcome to D period, Algebra 2. It's Monday, May 18th. We're one class away from being done. I've got a few announcements. You may have heard in the earlier class that Father Adrian passed away this morning at 2 a.m. It's a little bit somber here at school today, but I think the monks are going to have kind of a low-key ceremonial event on his behalf. I think it's just going to be pretty Father Adrian's family members and the monks, and then they hopefully will intend to do something larger, maybe late summer, early fall when we're all back together again. That's kind of the somber news. The good news is they were here with a big crane early this morning, put a huge copper cross on top of the bell tower. It looks pretty amazing. They had drones out there filming it, and just about 30 minutes to an hour ago, they had a kind of in the gym to two contributors, the Reynolds family, Sean's family that graduated in 2015 and passed away, and the McMurtry's. I think it's the gym's going to have both those.
Is that Carl McMurtry's family?
I believe, yeah, I believe so. I know the Reynolds. I don't know the McMurtry's, and I don't know if I've ever had them, but I assume that's, since that's a unique name, it's got to be one that's.
Yeah.
So the gym looks real good. It's coming down to the finishing touches. So, okay. Last announcement is they asked us to remind you this morning that Thursday is the last day of the quarter. So if you've got old, late, or missing work to submit, check behind me in Blackbaud. You may be sitting there pretty happy that you've submitted everything, but I've still got probably 2 dozen to 2.5 dozen various worksheets and quizzes over there that don't have a name on it and don't have any unique writing that I can place a name on them. So check behind me to make sure I've got you scored correctly for everything you've submitted. And if something is missing, just look at the number on Blackbaud and resubmit it. So hopefully it's sitting there on your desk or in your notebook. Make sure your name is on it so I can get that up to date, because they told us to be not real flexible at Thursday's the last day for late work. All right. Any comments on that? Any questions? Again, check behind me. I mean, we had some Blackbaud problems, when I think Blackbaud caught the COVID disease also, and for a while there it was down for like 6 or 7 days. So I got I got behind, but I think I got it caught up. And then again, on top of that, these assignments that don't have names on them, I don't want to unfairly penalize you if you've done the work and it either got lost in technology or you didn't put your name on it. So check behind me to make sure I've got what I'm supposed to have for you. Questions or comments on that? Okay, here's kind of the plan for the day. We're going to wrap up the last section for the year, which is at 6.6 rational exponents and radicals, problem set number 2. And my computer pen was acting up my stats class earlier today, so I think what I'm going to do is I just photocopied my answer key, so I'm going to just use my answer key and then write on that too, just in case my pen gives out again, or maybe it's not even working once I put it up there. And then what I'd like to do is, I'm not going to quiz on 6.6. What I'd like to do is, this is our third and final section of chapter 6. We did 6.4, 6.5, and 6.6. All very similar, all dealing with radicals and exponents. And I'm going to pull about 10 questions. Most of these are short answers. Some of them you're doing on your calculator, and I'll do a quick review at the end of class if you'd like. And pull about 10 questions from each section, 8 to 10. So it'd be a 24 to 30 question. It'll look like a blown up quiz. I'm going to score it as a test. So we've got more than one test this quarter. And I'm in the middle of constructing it. And I should have it up online by 8 a.m. tomorrow morning, or let's say 9 a.m. tomorrow morning. I may have it up tonight. I'm about a third of the way through, depending on what happens the rest of the day. And then I just ask that you take it before the start of class on Wednesday, which is our last class, so that if I'm missing it, I can push you along to make sure you submit it. And that will wrap up Algebra 2 for this year.
Wait,
I'm sorry?
we had a test this quarter?
Did we have one that I did at the end of third and I carried to fourth? I'll have to go back and look at Blackbaud.
Okay, because I didn't see anything for a test. Like, it's just nothing there.
Are you looking right now?
Yes, sir. It's just like there's no like down bar for tests at all.
What do you mean down bar?
Like, you know how you can click on it and you like press the bar to, and they pop up with like what you got. It doesn't show anything. Like, it's just.
I know what you're saying.
Okay.
I thought we had. Let me just look my notes real quick here. I could be wrong. It's been a crazy quarter. I don't know. Let's see. I thought there was one that we did in third that I carried over to fourth because we had, because right at the end of the third quarter, the last week of the third quarter was, we were already out in this COVID stuff. I don't see it, so you may be right. Don't get too hung up that it's a test. I don't think the grades will be low since this is pretty straightforward, but if they are, I will cover it appropriately. Okay. All right. Any other questions, comments? Okay. Everybody's got 6-6 number 2 there nearby. Let's see.
Yeah. Yes.
Hopefully this will show up. All right, and I'm going to just do some reminders. Let's see if okay, good it is. Okay. All right, so 6-6 was rational exponents and radicals. We're kind of jumping. We're converting exponents to radicals, radicals to exponents, and that's what we're doing here. Let me see if I can get this thing a little. Yeah, it's big enough. See if I can pull this up just a bit. There we go. All right, so let's talk and check your answers against these, and let's talk through them if we're struggling with solving them. All right, number 1, identical bases, so we add the exponents. So when the exponents are actually fractions, and as you know, when you add fractions, you have to have a common denominator, which you do in this case. So the common denominator just rides as is. 4 plus the 6 is 10. 10 over 5 is same as 2. It can be simplified to 2, so it's x squared. Again, stop me if you see something like I don't know where that came from. All right, here our exponents have exponents. And remember, with these, we actually multiply the compound exponents. So the 2 times the 3 is 6, and the 3 times the 4 is 12, and it's y to the 1/2. And these two are y to the 1/2 and the square root of y are the same thing. Make sense? All right, number 2 is like number 1, except you weren't given common denominators, so we had to convert the 4/5 to 8/10. 8 and a 7 is 15. 15 over 10 is simplified to 3/2. So it's p to the 3/2. Number 4 is like number 2, so we just multiply 6 times 2 is 12, and 5 times 5 is 25. How'd we do on those? Good. All right, hearing no comments, we will proceed. Sometimes my work got a little scratchy. All right, so let's talk about these. All right, so on this one we had to get, oops, come on, man. We had to get a common denominator, which the least common denominator is 24. So we had to convert the 3/8 and 4/3 to 24, which we did here. And then we add the 9 and the 32 for 41 over 24. Kind of a crazy radical there, or crazy exponent. Actually, no, I was going to say, I was thinking 3 went into 41, but it doesn't. Or you could have simplified that. All right, number 6 is like 2 and 4. We just multiplied. 4 and 1 is 4, and 6 and 3 is 18. We had 4 18ths. Now, if you get something like this and you can simplify, always simplify it, and it can be simplified to 2 ninths. All right, number 7, you needed to think a little bit, all right? And again, kind of get exponents or common exponents. So p to the first is the same as p as 3 over 3, right? Now, when we're dividing, instead of adding the exponents, we're subtracting. So, and we got common denominators, which is great. So the 3 minus 1 is 2. And so it's p to the 2/3. Everybody get that one? That one you had to think a little bit. All right, number 8's done kind of the same way. You had to get common denominator of 6, something over 6, so we converted those. So we got 3 over 6. 3 minus 2 is x to the 1 over 6. Or another way you could express that, just we know how to go back and forth, is x to the 6th root. Everybody good? All right. Okay, let's see here. 128. If we did the old 144 and kept going, you'll find that 128 is 2 to the 7th power, right? 128 is actually 2 to the 7th power if we worked it all the way down. So it's, so we could pull 2 to the, there's a 2 to the 6th times 2 under that radical is another way to express it. 2 to the 6th times 2. So 2 to the 6th, and the 6th root of that comes out just as 2, and there's still a 2 under the radical. We good? All right. Number 10, had to think a little bit. 49 we're so familiar with, we know that's 7 squared. So to begin solving it, I rewrote it as this, right? It's 7 squared, it's the 4th root of 7 squared. And then I went from the radical formatting of that to the exponential formatting of that. And always remember, the exponents on the top and the root, like on a tree, is on the bottom. So we have 7 to the 2/4, which then could be simplified to 7 to the 1/2. So I would have taken this answer or this answer, because it's the same thing. One's in radical form, one's in exponential form. You good? Any confusion? Anything? Are we getting these answers? Yes?
Yes, sir. Do we have to turn this in?
No.
Okay, I figured. Okay.
Okay.
All right, let's see. We did that one. Let's see, we're on 11. Let me see. I'm trying to think how I solved that. Okay, yeah. Here you just had to make your kind of pyramid. It ends in 288, so I'm going to start seeing if I can factor out 5 2s out of there. And that's what we did. All right. I tried something, I saw the 144. Well, 144 is the same as 12 squared. That's 12 times 12, but that didn't move the needle any. But so we keep going. We end up with 2 to the 5th power times 9, which was, let me see here. 1 second. Yeah, it's 2 to the 5th is 32. And 32 into 288 is 9 times. All right. Don't get tricked in trying to bring that out as a 3, because it's not a square root, it's to the 5th root. Questions? I'll keep going if you don't ask any questions. All right. Let's see what we did here. All right. There's a couple different ways you could approach this, and I tried different ways. You may have done it slightly different. Well, the 32 is 2 times 16. All right. And 16, we know, is 4 squared. So the 4 comes out from the radicals or the 16 comes out from the radical as a 4, leaving 2 still under the radical, which I couldn't simplify any further. The 16 comes out from another radical as a 4. 4 times 3 is 12, and then we just multiply this whole thing. So it's 48 radical 2 or square root of 2. Are we good? I'm hoping the silence means we're getting this.
Yes,
I
sir.
got it.
We're getting it.
Ask questions if I'm saying something that's like, I don't know what you're talking about or where that came from.
Okay,
Okay.
sir.
All right, let's see. I have to rethink how I did this. Oh, yeah. Knowing that this was all divisible by 5, this is kind of a weird one. I just converted the radical format to the exponential. So 25 is 5 squared, and then it's the cube root of 5 squared. And then 125 is 5 cubed, and it's the square root. Now, so then, let's see what we did here. Oh, we had, since I've got like bases, I can add the exponents, right? But I need to have common denominators for the fractions, right? So 2/3 is 4/6, 3/2 is 9/6, 4 and the 9 is 13, so it's 13/6. Now, I'd be happy with that answer. Now, I mean, you could also express it as, well, you could express it as, that seems like a large number. You could express it as this. I'd take that also, unless it says put it in exponential. Or what your textbook answer it came up with, which was kind of unusual for how the others were answered, is how many times does 6 go into 13? Twice, right? So it's 12/16 or 12/6 is squared, right? So the way they actually did it was, which doesn't, it's kind of a weird format. If you did this, you'd get credit for it. But to me, it's a little, it's not typical of how we're answering the other ones. So I'm not looking for the answer. Of course, if you did it, that is right. So it's 25 times 5 to the 1/6, which is, like I said, it's kind of a different format than what we've been giving them. So I would be happy if you gave it to me as this format, either one of those. All right, so let's look at this guy. 16, that 16 is a commonly used number. It's the same as 4 squared, right? We're taking the 6th root of 4 squared. So, I mean, it's the same as 4 to the 6/2, right? Oh, excuse me. That's reversed. It's 4 to the 2/6. The root is on the bottom. Sorry about that. All right. 2/6 can be simplified to 1/3. So again, either one of these is good answers. It's the same. It's 2 different ways of expressing the exact same thing, right? 15, I didn't like that problem at all, but I'm going to talk about it since you may have tried to unravel the tangled web. All right, so I converted both the numerator and denominator to exponential forms, and then kind of looked at them vertically. All right, so I had 8 over a to the 1/2. So that can be simplified to 8 to the 1/2 on the top. And here we had b to the 4/3 over b to the 3/2. And again, just doing common 4/3 is 8/6, 3/2 is 9/6. That's the same as b to the 1/6 in the denominator position. So it's kind of a weird answer, and I'm not real big in this question, but either one of those answers, they both express it mean the exact same thing. It's just 2 different ways of expressing it. All right. Any questions? Any confusion on radical exponents or rational exponents and radicals?
No, sir.
Are we getting those answers? Is there anything do I need to throw a few more up for practice, or are we pretty comfortable with these?
I'm pretty comfortable.
All right. So I was going to just real quickly go back and look at, this was 6.6. I was just go back and look at a couple things on 6.4 and 6.5 real quick, just as a refresher before you take the 6.4, 6.5, 6.6 test. Like I said, it's 3 sections. It'll probably be no more than 30 questions. Could be, I'm going to pull like 10 from each section or 8. So it's going to be somewhere in the 20, probably 25 to 30 range with probably 2 bonuses. Okay.
Love math class.
Cornette's still having fun, or is that?
Sure, that wasn't me. That was not me.
That was Bigelow. See, I can tell where the noise is coming from. I got a secret decoder ring on how to decipher that.
Sure, that wasn't me.
Are you sure?
I was just laughing.
Sure, Biggs? Are you sure?
I'm sure.
Okay. No. You can check the videotape, sir.
Let's go to the tape.
Rewind.
I'm just bear with me. I'm loading up a couple things here. So we got him. Okay, now let's see if I can, this guy don't need any more. So I want 6.4 quiz. There we go. All right. Everybody see that where it says nth root quiz? Everybody see that okay? Yes?
Yes, sir.
All right. Okay, just a couple things. Read the instructions. Don't let not reading the instructions mess you up. All right. All right. Here you just use a calculator. We're just going to solve these. All right. They're not perfect squares. You can tell that right off the top. So just plug them into the calculator. Be careful. If it's asking cube roots, okay, be careful. All right. And a couple you got burned on it. Round to 3 decimal places. So let's say you come up with an answer of 5 point, say you come up with an answer with 5.4755. Okay, and let's keep going. 6, 7, 8, 9. All right. So if we're going to round to 3 decimal places, all right. Come on. All right. All right. We're going to round to 3 decimal places. Everything to the right of that line goes away. Just as a reminder, if this number here, the first one that you are removing, all right, 3 decimal places is 3 to the right of the decimal. If this first number that you're removing is 5, 6, 7, or 8, or 9, this becomes a 6. If this number is 0 through 4, the 5 just stays as is. Everybody clear on that? Any
Yes, sir.
question? All right, let's look at this. Somebody tell me something that's going on with number 4. Can I solve that? How about that?
Really fun.
I couldn't hear you say, Mr. Carmen. All right, this is the stuff you got to know. I cannot solve this. Why? Because it's an even root with a negative under the radical. Not solvable, no solution, right? Not solvable, no solution, because there's no 2 numbers I can multiply and get a negative product. Remember? All right, how about this guy, number 6? Can I solve that one? Anybody?
Yes, you can.
You can. A negative under the radical is fine as long as that root is an odd root, 3, 5, 7, 9, 11. Okay? Be careful. Make sure you know how to do these roots other than square roots with your calculator. If you don't know how to do it, my suggestion is just Google how to calculate roots on a TI X3214, whatever you have. I'm sure there's a YouTube video or a written explanation on Google that will help you on how to do that. So make sure you read the instructions on that. That's really free money here. You just plug it in the calculator. All right. Notice the difference. 1 through 6, we're using a calculator to approximate each value. We're approximating because we're rounding to 3 decimal places. Most of these are irrational answers where it keeps going on and on and on. Remember the old I's? Irrational. All right, number 7 on down is simplifying, meaning we're going to pull the perfect roots out from underneath that radical, okay? Take a look at these. Let's talk about a couple of them. Remember the deal where if you can rewrite those, if you look at the top of problem set 1 from this section, if it helps you to solve it or simplify it, you can rewrite it to help you do that, all right? So that's 2 over, it's a negative. There's a negative outside those radicals that just kind of goes along for the ride. You don't have to do anything with it other than carry it along, all right? This guy here is solvable because it's a negative under the radical, but it's an odd root, so it's a -2. Because -2 times -2 is 4. 4 times -2 is a -8. The square root of something squared under the radical, you shouldn't even have to think about it or plug it in your calculator, is whatever that is you're squaring underneath the radical. Okay? Any questions on those? Any confusion? See if there's anything else. Let me talk about. Okay, let's talk about number 15. All right. Treat this as kind of like 3 separate little mini problems within the one big problem. The negative just comes along for the ride. I look at the 100. We love 100 because that's 10 squared, so that comes out as 10. The square root of p to the 4th, p to the 4th is the same as p squared times p squared, so that comes out as p squared, right? And t squared, the square root of t squared is t times t, right? So that just comes out as t. These should be easy money, right? Just like 4th root here, the 16 comes out as 2 because 2 to the 4th power is 16. The w to the 4th comes out as w, right? Because it's w times w times w times w, right? So it's w. It's the 4th root of. It's the same as if you could actually put it in exponential form, all right? Which is the same as w to the 4th over 4, right? Which simplifies to w. Just like the v comes out as v squared because it's 8 over 4, right? Any questions on that? That makes sense.
Oh, sir.
And I think that was all of 6-4. Let's see. Yep. Everybody's good? I want everybody to get 90 plus on this. Because you can maybe repair some damages from earlier. All right, let me clear this. All right, so that's 6-4. We went over 6-6 at the beginning, so let's take a brief look at 6-5 and then we'll be done. Let me stop share. Put that one away. Go to renew share. Let's see, 6-5. All right, let me grab my 6-5. Okay. On these, when it says, this is kind of like those other ones that were perfect squares. These aren't perfect squares, so they want you to pull anything perfect out. We're not solving, we're simplifying. We're going to pull out anything perfect, any perfect squares out from underneath the radical. So 28, all right, what's my multipliers of 28? It's 4 times 7. Or if you didn't know that, you could, or didn't recall that, you could do the old 28, that's 2 times 14, and then it goes 2 times 7, right? So we got 2 times 2, so that's a perfect square. So the 2 comes out and the 7 stays under the radical. Right? 50 is 25 times 2. The 25 comes out front of the radical as a 5. Square root of 25 is 5. And the 2 stays under the radical. Bring back memories.
Yes, sir.
Let's see. Take a look. Do we need to talk about any of these?
No, sir.
Take a look. Let's see. Let's look at 7. Let's look at 7. Just for a refresher. All right. All right. So again, look at this as kind of 3 little mini problems: the -8, the D, and the F. All right. We're doing cube roots, so don't forget. Don't treat it as a square root. So the negative is fine, and we've used -8 or 8 is 2 cubed, right? So that comes out as -2. D cubed is D times D times D, so I got D to the 3rd power, so it's like D to the 3 over 3, so that just comes out as a straight D, right? And then the F comes out as F to the 6th over 3, or F squared. And we're done with that. All right. Let's see here. Let me look at the back side here and see if there's anything I need to go over. Come on, scroll for me. Yes. Let's talk about these. You guys are quiet today. Must be that uniform deal. All right.
It is.
All right, let's talk about these. All right, look at number 9. All right. So if I multiply 3 times 5, that's 15, right? And then I multiply the square root of 3 times the square root of 3 is the same as 3, right? That's like 3 squared, the square root of 3 squared, right? And then that equals 45. All right. All right, this one here we're foiling, right? So if I foil this, and if you notice, this is that complex conjugate stuff that we've dealt with off and on over the last 10 weeks or so. So if I know my O and my I are they're opposite, same numbers with opposite signs, so I know they're going to cancel each other out. So if you can foil, get the same answer, but if you recognize that, you can cut your workload in half. So the only thing I really care about is the F, which is 1 times 1, and the L, which is the square root of -5 times the square root of +5. All right, so that's going to be 1 minus 5, right? It's like 1 minus 5 squared. And so that's going to be a -4. Easy money. All right. Now, let's look at numbers 11, 12, 13, and 14 are all handled the exact same way. All right. Remember, it says this is the like terms of radicals. And like terms of radicals means they've got the same exact expression underneath the radical sign. All right, so I can't simplify this guy any. 8 is 4 times 2, right? So this can be rewritten as 2 radical 2, right? And 50 is 25 times 2, so that can be written as 5 radical 2. So now I've got 3 like terms. I've got 3 things that are like terms, right? So it's radical 2 plus 2 radical 2 plus 5 radical 2, so that is 8 radical 2. All right. Let's just do one more just for a refresher. I can't simplify this thing any, so I like that 3 under the radical, so I'm going to divide this 12 by 3, and I get 4 times 3, which is perfect, because now I got 12 is 4 times 3. The 4 comes out from under the radical as 2 radical 3, right? And so I got 2 radical 3 minus 2 radical 3, so that zeroes out, all right? So let's see how I can simplify 108. Well, since they were doing radical threes, I'm going to divide 3 into 108. If I divide 3 into 108, I will get 36 times 3, right? 36 times 3 equals 108. So that we love 36, perfect square, comes out as 6 radical 3. And we're done with that guy. 13 and 14 are done the same way. Any questions or clarification on those guys? Okay. What are you guys doing? Watching The View or Jerry Springer or what? Or you already just know all this? Let's see. Actually, that's everything. So look over your 6-4, 6-5, and 6-6 problem sets and quizzes. That's what's going to come from. And it'll be somewhere between 25 and 30 problems. I hope to have it up tonight sometime. Just take it before the start of class on Wednesday. All right?
Yes, sir.
All right. So we got 9 or 10 minutes left. What can I go back? Is there anything I need to go back over and talk about?
I'm personally good.
All right.
I'm good too.
That's all. Anything we need to talk about? Anything we need to talk about? Let's see. Gabe Myers, you still out there? Looks like we lost you. 11.
Yeah, where is Gabe?
He checked in, but then he quietly disappeared. Okay, so moral of the story. Again, Thursday's the last day for late stuff. So go back, make sure you don't have any M's.
Yes, sir.
That may be due to technical difficulties. You're not putting a name on something or something. And get that to me by Thursday. Okay, I'll post the tests sometime this evening, and then make sure you do it by Wednesday. So that gives you a day and a half. Okay, so I can kind of prod you along if I don't have it when we check in on class on Wednesday, which will be our last class. All right. Any questions, comments, concerns?
Oh, sir, can you send me the PDF version of that one quiz that I missed again?
Yeah. Thank you for reminding me. I gotta give me a few minutes after class is over, and I'll send it your way.
All right, I'll probably have that in before class. I'll probably just turn it in alongside with the quiz.
Don't send them on the same email. They're the same Dropbox.
All right, I'll email it to you then.
Okay. It just could possibly get lost in the shuffle. All right. The other burning issues.
Do you think those two quizzes would bring my grade up a lot?
Well, anything better than 0 will bump that grade up. M's are mathematically calculated as zeros.
Okay.
Unless you just missed every question on the quiz.
Yeah. I won't.
Which hopefully that didn't happen.
I won't.
Reflect bad on you and me.
Yeah.
All right. Any other burning questions?
I have a question about the Patrick JMT problem set on operations with polynomials.
Yeah, JMT is like Khan Academy, okay? And we
Okay.
used it, and I've referenced you guys to use it. Just Google it, and you can go to his website, and then he's got a search box there. So whatever the topic of the section is, you can type that in the search box, and he could have anywhere from 2 to 4 or 5 videos on it. It's similar to Khan Academy, but I think it's a little more earth, literally and figuratively.
What problem set do we complete from it? It says operations with polynomials, but is that on Blackboard?
Where are you reading this from?
Missing work. I mean, Yeah, from missing classwork I have.
What day was that?
Oh, that was a while ago.
Well, you gotta give, I mean, I can't tell you. You gotta tell me,
Sorry.
like, my notes here and tell you
It
what
was
it's referring to.
March 28th.
March 28th. You turned that one in. That was one I just got. March 26th with 5-1.
Oh, yeah, 26.
26th. Yeah.
Oh, I found it.
Okay.
Okay, we're good.
All right. Anything else?
No, sir.
All right. Everybody have a good couple days. Don't forget the test. Give me till tonight to get it up and read the instructions. Avoid careless errors. Double check your work before you drop it in the Dropbox. Make sure you read the instructions and do exactly what it says. Make sure you round correctly. All right. Get everything you can out from underneath the radical. Sometimes changing that radical format to an exponential format makes it easier to solve or simplify.
Okay.
All right.
I'll be
When is the
sending.
test due?
If you have a question, I got office hours 2 to 2:30 every day. Okay.
I'll be sending in the stuff. I'll have 2 more things.
Okay.
When is
All
the
right, thank
test due?
Say again, Mr. Rattler.
When is the test due?
Before class on Wednesday, so I can kind of wrap you upside the head if you didn't turn it in by then.
Okay.
That's our last day.
All right.
All right. Shouldn't take you but 25 minutes. All right. We'll see everybody.
Bye, sir.